Here is a question for you. How do you find the indefinite integral of that? We have a 3 product term expression. How do you integrate that? Perhaps you're familiar with integration by parts, and you've seen this formula. The integral of u dv is equal to u times v minus the integral of v du. Now, this works for a 2 product term expression. But what about a 3 product term expression? Well, before we can derive the formula that will help us get the answer, let's talk about how we can derive this formula, because if we can understand that process, we can apply it to a 3 product term expression. We need to start with the product rule. The integration by parts is basically a reverse, or the reverse process of finding the derivative using the product rule. So let's say we have a 2 product term expression, u times v. The derivative of u times v is going to be, you take the derivative of the first part, u, which becomes u prime, times v, plus u times the derivative of the second part, v prime. So that's the product rule. Now, u prime, if we differentiate it with respect to x, is going to be du dx, and v prime is going to be dv over dx. So what I'm going to do at this point is multiply every term by dx. So I now have uv prime dx is equal to v du plus u dv. So at this point, what I'm going to do now is I'm going to move this term to the other side. So I have uv prime dx minus v du is equal to u dv. Now I'm going to reverse the equation. I'm going to take this, move it to the other side, and this, move it to that side. So reversing the equation, we're basically just switching it. I have u dv is equal to uv prime dx minus v du. So now let's take the integral of both sides. So this becomes the integral of u dv. The integral of uv prime is just going to be uv, because here you're taking the derivative and then you're integrating it, which are basically reverse processes of each other. So it's like a double reverse. So you just get uv minus the integral of v du. So that's a simple way in which we can derive the integration by parts formula from the product rule of finding derivatives. Now let's apply that same process to a 3 product term expression. So let's find the derivative of u v w. So first we need to differentiate the first part. So we're going to get u prime, leaving the other 2 the same. Next we need to differentiate the second part, that is v, so that's going to be v prime, leaving u and w the same. And then we're going to differentiate the third part, leaving the first 2 variables the same. So that's how we could find the derivative of a 3 product term expression. So now at this point, let's replace u prime with du dx, and we're going to replace v prime with dv dx, and w prime with dw dx. And like before, we're going to multiply every term by dx. So these will cancel. And so we're going to get u v w prime times dx, and that's going to equal v w du plus u w dv plus u v dw. Now I'm going to take these 2 terms and move it to the other side. So I'm going to have u v w prime dx minus VW du minus UW dV, and that's going to equal UV dW. Now I'm going to reverse both equations. So we're going to have UV dW is equal to UV W prime times dx minus V W du minus U W dV. Now we're going to integrate every expression, or integrate both sides of the equation. So the final answer is this. The integral of U V dW is going to be, this becomes just UVW minus the integral of V W du minus the integral of U W dV. So this is the integration by parts formula for a three-product term expression. So let's apply this formula to the original problem. So we had the integral of x sine x e to the 2x dx. So u is going to equal x, v is going to be sine x, dw is going to be e to the 2x dx. So if u is equal to x, du is going to be the derivative of x, which is 1 times dx, which we can simply write as dx. V is equal to sine x. The derivative of sine x is cosine x. So dv is going to be cosine x dx. dw is e to the 2x dx. The antiderivative of e to the 2x is going to be e to the 2x divided by 2. The derivative of 2x is 2. So now this is going to be UVW, so that's x sine x times w, which is e to the 2x over 2, minus the integral of v, which is sine, times w, which is e to the 2x over 2, times dv, which is dx, minus the integral of u, which is x times w, times dv. dv is cosine x dx. So we have a lot of integrals to deal with here. But what we're going to do now is we're going to focus on this integral that we see here. So that is 1/2 the integral. I took the 2 and moved it to the front. So there's the 1/2 symbol. 1/2 the integral x e to the 2x cosine x dx. Now we need to use this formula again. So we're going to make u equal to x. So du is dx again. And let me rewrite it. I'm going to write it as x cosine x e to the 2x. So v is going to be cosine. The derivative of cosine is negative sine. And then dw is e to the 2x dx. So w is going to be the same thing, e to the 2x divided by 2. So now let's put it together. So we have UVW, that's x cosine x e to the 2x over 2, minus the integral of VW du. V is cosine, w is e to the 2x over 2, and du is dx. And then minus the integral of UW dv. U is x, w is e to the 2x over 2, and dv is negative sine x dx. So notice that this expression is similar to the original one. So therefore we can combine those two integrals later. So we just need to worry about this one. But now let's move on and deal with this integral. It's a two-product term expression. So we're going to have 1/2 the integral of sine x e to the 2x. So we're going to use this formula. The integral of u dv is equal to uv minus the integral of v du. So u is going to be sine x. du is going to be the derivative of sine, which is cosine x dx. dv is going to be e to the 2x dx, and so v is e to the 2x over 2. So this becomes u times v, so that's 1/2 sine x e to the 2x minus the integral of v du. So that's e to the 2x over 2 times du, which is cosine x dx. So notice that eventually we're going to be able to combine these two expressions. So at this point, what we want to do right now is take these terms and plug it in to their respective formulas. Now, one thing that we have yet to do is distribute the 1/2. So let's go ahead and do that now. So multiplying everything by 1/2, this becomes 1/4. And this becomes e to the 2x over 4. Now we need to do the same with this expression. So let's replace all the 2's with a 4. So this would equate to dividing every term by 2, or multiplying it by 1/2. So now the original expression, x sine x e to the 2x dx, is going to equal this. So that's 1/2 x sine x e to the 2x, and then minus. Now replacing this expression with what we see here, it's going to be minus 1/4 sine x e to the 2x, and minus that expression, so that's going to be plus 1/4 the integral of cosine x e to the 2x. And let's not forget dx. So now we can move on to this one. We do have a negative sign, so keep that in mind. So it's going to be minus. So we're going to replace this with everything that we see here. So it's minus that term. So that's going to be 1/4 x cosine e to the 2x. And then we have minus and another minus, so that's going to be positive, which I'm going to put right under this expression because we can add them. So positive 1/4 integral cosine x e to the 2x. And then we have minus, minus, minus. 3 negatives, that's a negative. So minus, let's move the 4 to the front. 1/4 the integral of x sine x e to the 2x dx. So what I'm going to do now is I'm going to take this and move it to the left side of the equation. So we have 1 plus 1/4. That's 4 over 4 plus 1 over 4, which is 5 over 4. So 5 over 4 integral x sine x e to the 2x dx is going to equal 1/2 x sine x e to the 2x minus 1/4 sine x e to the 2x. 1/4 plus 1/4 is 1/2, so plus 1/2 integral cosine x e to the 2x dx, and then minus 1/4 x cosine x e to the 2x. So now let's eliminate this, and let's focus on this integral. The integral of cosine x e to the 2x dx. We'll deal with the 1/2 later. So we're going to make u equal to, let's put this on the bottom here. Let's make u equal to cosine x. So du will be negative sine x dx, and dv is e to the 2x dx, so v is going to be e to the 2x divided by 2. So using the formula for a two product term expression, it's going to be the integral of u dv is uv minus the integral of v du. So u times v, that's going to be 1/2 cosine x e to the 2x minus the integral of v du. So this is v, this is du. That's going to be negative sine x e to the 2x over 2 dx. So the two negative signs will cancel. That's going to be positive, and we can move the 1/2 to the front. So this becomes plus 1/2 the integral of sine x e to the 2x dx. Now we need to use integration by parts one more time. So this time we need to make u equal to sine x. Du is going to be cosine x dx. And dv is going to be the same. So this is equal to 1/2 cosine x e to the 2x plus 1/2. And now let's apply this formula. So it's uv, that's going to be 1/2 sine x e to the 2x minus the integral of v du, which is 1/2 cosine x e to the 2x dx. Now let's put this all together. So the integral of cosine e to the 2x dx is going to be 1/2 cosine x times e to the 2x. And then 1/2 times 1/2, that's going to be plus 1/4 sine x e to the 2x. And then we have 1/2 times negative 1/2. So that's negative 1/4 integral cosine x e to the 2x dx. So now we can combine these two expressions. So add in 1/4 integral cosine x e to the 2x. This is going to be 1 plus 1/4. So we have 5/4 integral cosine x e to the 2x dx, which is equal to this. Now, we're not trying to solve for 5/4 cosine x e to the 2x. We want to find the value of just one of it. So to turn this back into a 1, we need to multiply everything by 4/5. So the 4's cancel, the 5's cancel, and we're going to get our original expression. 4/5 times 1/2. 4/2 is 2, so this becomes 2/5 cosine x e to the 2x. Here the 4's cancel, so that becomes 1/5 sine x e to the 2x. So the integral of cosine x e to the 2x is 2/5 cosine x e to the 2x plus 1/5 sine x e to the 2x. So we need to replace this expression with what we have here, and then combine like terms. So 5/4 integral x sine x e to the 2x dx, that's going to be 1/2 x sine x e to the 2x minus 1/4 sine x e to the 2x. And then we have plus 1/2 times everything here. So times 2/5 cosine x e to the 2x and then plus 1/2 times this, that's times 1/5 sine x e to the 2x, and then that one, minus 1/4 x cosine x e to the 2x. So we can combine those expressions. So that is negative 1/4 plus this is 1/10. So getting common denominators, so we need to get to 20. We're going to multiply that by 2/2 and this by 5/5. So we get negative 5/20 plus 2/20, which becomes negative 3/20. In case you're wondering why the screen looks a little different, there's no cause for concern. I just had to do some video editing. So let's put everything together at this point. So these expressions combined, we said it's negative 3/20 sine x e to the 2x. And then these will cancel, so we're going to get plus 1/5 cosine x e to the 2x, and then minus 1/4 x cosine x e to the 2x. Now, we need to replace the 5/4 with a 1. So we're going to multiply every expression by 4/5. So the 4's will cancel, the 5's will cancel. On the left, we're going to get the integral of x sine x e to the 2x. These will cancel. 4 divided by 2 is 2. So this will give us 2/5 x sine x e to the 2x. 3/20 times 4/5. That requires some work. 20 can be written as 4/5. And so we can cancel the 4, which will give us 3/25. And then we can multiply these two. 4/5 times 1/5. That's going to be 4/25 cosine x e to the 2x. And then these will cancel, giving us negative 1/5 x cosine x e to the 2x plus c. So thus we have our final answer, which I'm going to write on the top of the screen because we're going to check our work soon. So the integral of x sine x e to the 2x dx is equal to 2/5 x sine x e to the 2x, and then minus 3/25 sine x e to the 2x minus 1/5 x cosine x e to the 2x, and then plus 4/25 cosine x e to the 2x plus c. So this is the final answer. So that's how you could find the indefinite integral of a 3-product term expression using integration by parts. Now, in order to make sure that this answer is indeed correct, we're going to take the derivative of the right side of the equation and make sure we get what is on the left side. So let's take the derivative of the first term, 2/5 x sine x e to the 2x. So we're going to use the product rule given this 3-term expression. First, we're going to differentiate the first part, 2/5x. The derivative of x is 1, so it's 2/5 times 1. And then we're just going to multiply by the other two products, sine x e to the 2x. Next, we're going to leave the first part the same. We're going to take the derivative of the second part. The derivative of sine is cosine, and we're going to leave the third part the same. For the last one, we're going to differentiate the third part, which is e to the 2x times 2, leaving these two the same. So 2 times this will be 4 over 5x sine x, and then e to the 2x. Now let's take the derivative of the next term, that is of negative 3 over 25 sine x e to the 2x. So we need to use the product rule again, but for a two product term expression. Let's say this is u, this is v. So the derivative of the first part is going to be negative 3 over 25 times the derivative of sine, which is cosine. And we're going to leave the second part the same. Next, we need to differentiate this part, e to the 2x, which is just e to the 2x times 2. So negative 3 over 25 times 2, that's going to be negative 6 over 25 sine x e to the 2x. Now, moving on to the next term. The next one is going to be negative 1 over 5 x cosine x e to the 2x. So we have a three product term expression. The derivative of negative 1 over 5x is just negative 1 over 5. And then we're going to have cosine times e to the 2x. The derivative of cosine is negative sine, so this is going to be positive 1 over 5x sine x e to the 2x. And the derivative of e to the 2x is the same thing times 2. So it's going to be negative 2 over 5x cosine x e to the 2x. Now for the last one, 4 over 25 cosine x e to the 2x, we have a two product term expression. The derivative of cosine is negative sine, so we're going to have negative 4 over 25 sine x e to the 2x. And then the derivative of e to the 2x is going to be that times 2, so 4 times 2, that will be 8 over 25 cosine x e to the 2x. So what we're going to do is add these terms and see if we get this. So let's think about what cancels. So these two terms cancel. Let's see, what else? Let's focus on these three. Negative 3 over 25, negative 1 over 5. If you multiply that by 5 over 5, you get negative 5 over 25 plus 8 over 25. That adds to 0. So therefore, we can cancel these three terms. Now, let's talk about these numbers here. 2 over 5. Multiplying that by 5 over 5, that's going to give us 10 over 25. And then we have minus 6 over 25, minus 4 over 25. That's going to give us 0 as well. So we could cancel those three terms. So what we have left over is the sum of these two. 4 over 5 plus 1 over 5 is 5 over 5, which is just 1. So we get 1x sine x e to the 2x, which is our original expression. So therefore, this is indeed the correct answer. So that is the integral, or the antiderivative, of x sine x e to the 2x. So now you know how to apply the integration by parts formula when you're dealing with a three product term expression. So that's it for this video. Thanks again for watching.